Hey guys, I'm going to go over the 6.7, 6.9 through 6.9 homework. And so we're going to focus on antiderivatives, meaning basically what we're going to be using for a lot of this stuff right here is the integral from a to b of f of x dx is equal to f of b minus f of a. So that's what we're looking at doing right here using this formula. So select values, and then the last half is going to be doing integration through substitution. So for this first one right here, we have a table, and it says that we have a twice differentiable function f and f prime in the table above. What is the value of this integral? So an integral can be evaluated. So this is f prime of x dx, and that's going to be equal to the antiderivative of f prime, which would be f of x, but specifically f of 6 minus f of 0. And so what I need from this table is just f of 6, which is 2, minus f of 0, which is negative 22. So that's going to come out to be positive 24, which is C. Okay, for 2, we have a calculator question, and it says g of 4 is equal to 0.325, and we have g prime given here. What is the value of g of 1? So let's say that I want to do the integral, the antiderivative. So I'm trying to find g of 1. I'm probably going to need the antiderivative of g prime. So we're going to say that the integral I'm going to use from 1 to 4. The reason why I'm doing that is so I can get antiderivative of 1 and antiderivative at 4, because I have antiderivative at 4 and I'm looking for antiderivative at 1. So the integral from 1 to 4, I'm just going to say of g prime of x dx, and this is going to be equal to g of 4 minus g of 1. Okay, and then, and I know that g of 4 is equal to 0.325. G of 1 is what I'm looking for. This is what I want, and I can use a calculator for this part since I have g prime. So that's what we're going to do. We're going to do the integral from 1 to 4 of g prime of x and get that answer, and that will help us find g of 1. So basically just using a little bit of algebra in that. So I'm going to go to math, option number 9. We're doing the integral from 1 to 4. And then we have, we're going to do 1 divided by x. And then that's going to be e raised to the negative x. And then we're going to have, goodness sakes, cosine of x divided by 100. And I get that right there. Okay, so round to 3 decimal places, that's 0.216. So 0.216. So 0.216. And if I want g of 1, I'm going to have to add this over, and I'm going to subtract this from that. Okay, so subtract this from that. So 0.325, 0.325, and then I'm going to subtract what I had from there, and I got 0.109. So 0.109 is right there. There you go. I'll just write that right here. G of 1 is going to be equal to 0.325 subtract 0.216. Okay, and for 3 we have another calculator. Let f be a differentiable function such that f of 0 is this, f prime is this. What is the value of f of 2? So this sounds like the exact same problem. So we're going to do, if I say the integral from 0 to 2 pi of f prime of x dx, that would be equal to f of 2 pi minus f of 0. Okay, and then I know that f of 0 is equal to 5.420, and I can use a calculator to get that right there. So we'll go to math, 0 to 2 pi, and then we're going to do the integral of the square root of sine of x. That needs to be squared, and then we're going to do plus x. And I get 11.448. So 11.448, and I'm going to add that over there. So add it. So plus 5.42. So plus 5.42, and I get 16.868. So that will be 68. I got rounding must be off a little bit. I don't know why. I thought I did it pretty flawlessly, but okay. Let's check 4. So this one's going to be, this is using substitution, so if you need to look at your notes for that. But essentially, what I'm trying to identify here is what I'm going to, what does this antiderivative look like? That antiderivative looks a lot, that looks an awful lot like I'm taking the derivative of arc sine. And if you remember the derivative of arc sine, the derivative of arc sine is equal to 1 over the square root of 1 minus x squared. And so I obviously want to take the antiderivative of this to get arc sine is what I'm thinking of, but I need to manipulate the inside part of this right here. So let's say that I factor out a 9. So I'm going to manipulate this expression to be the integral of 1 over the square root of 9. Now if I factor out a 9, that's going to be 1 minus x squared over 9. Like that. And then, see, I can take the square root of that, and I can actually, since 9 is 3 squared, I'm also going to manipulate that expression. So that's going to be the integral of 1/3, and then I'm going to have 1 over the square root of 1 minus x over 3 squared. So I'm manipulating this right here because x over 3 squared is x squared over 9. And so the reason why I've done that is now I can use u substitution right here. So let's say that I allow u to be equal to x over 3. And then if I, and then take the derivative of that, so du dx, but in this case I'm going to just write it as du is equal to 1/3 dx. And so rather than, typically we would say du over dx is equal to 1/3, but for the sake of solving for dx, well, we'll just say that right there. And then let's solve for dx. So if I solve for dx, dx will be equal to, so I'd multiply by dx and times by 3, so 3 du. And so now I have what I have all the parts I need to substitute. So this would, I'm going to put the 1/3 on the outside, and I have the integral of the square root of 1 minus, now we said that that was going to be u, so u squared over 1 times by, and for dx, we said dx is going to be equal to 3 du. Okay, now, as far as cancellations, that can cancel. So then I just have the integral of 1 over square root of 1 minus u squared du, which again, that's what I have right here. So the antiderivative of this will be arc signed. So this will be, I guess I'll just say sine -1 of u plus c, and then I can undo my substitution now. So I can just say that right there. So that's equal to sine inverse of x over 3 plus c, which will be d. Okay. For these last two problems, I think we're just using substitution. So again, these ones might be a little bit more straightforward than this one right here. It's kind of easier to see kind of easier to see what I need here. So if I look, what I'm trying to identify is there a part of this product that looks like it's the derivative of the other? So I know that if I take the derivative of this right here, this will become a third power, and that will become a 1 power, and maybe I can cancel it out with that right there. So let's say that I let u equal x to the 4th plus 2x squared plus 9. And du would then be equal to 4x to the 3rd plus 4x and over dx, sorry, du dx. And then I could say that du dx is equal to 4x to the 3rd plus x, and that's exactly what this part is, this product is. So I think I can cancel this out with that right there. So let's solve for dx though. So I get dx would then be equal to du over 4 x to the 3rd plus x. And let's make appropriate substitutions. So we're going to do the integral. Let's think here. Remember that these are in terms of x. And so yes, you can substitute at the end for x, but I'm going to put these in terms of u so that I don't have to undo my substitution. It's honestly not much of a difference, but this is just what I choose to do. So if I plug in 1 for this function that I have right here of u in terms of x, I'm going to get 1 plus 2 plus 9, so 9 plus 3, so that should give me 12. And then if I plug in 0, that's going to give me 9. So now these bounds are in terms of u, not in terms of x. And then I have x to the 3rd plus x. And remember that I'm making my substitution, so now this is going to be u to the 1/2, and dx is going to be equal to all of that right there. So it's going to be equal to du over 4x to the 3rd plus x. And as far as cancellations go, that's going to cancel with that. And then I'm going to put the 1/4 on the outside and the integral from 9 to 12 of u to the 1/2 du. So now I can do the antiderivative of u to the 1/2, which is just going to require the power rule. So that's going to, the antiderivative for u to the 1/2 is going to be u to the 3/2 power 2/3. But don't forget that I have this 1/4 on the outside, so times by 1/4. And then we're going to eventually evaluate this from 9 to 12. And then let me clean up my antiderivative part. So this is my antiderivative part, and eventually I'm going to do f of b minus f of a. And so that's going to be equal to, I think that's 1/6, right? 1/6, and then u to the 3/2. That's going to be evaluated from 9 to 12. Okay, and so now let's do the f of b minus f of a part. That's going to be equal to 1/6, and then I'm going to do 12 to the 3/2, and then minus 9 to the 3/2. Okay, and then that's going to be equal to 1/6. Looks like we're going to have to use some algebra, guys. So 12 to the 3 halves, just I'm going to do some scribble work, is the square root of 12 to the 3rd power, and the square root of 12 is going to be 2 root 3, I believe, and then that's going to be raised to the 3rd power, so that's going to be 8, and then that's going to be 3 times by 3 root 3, I believe, right? Because if you do root 3 times root 3 times by root 3, that's going to be 3 root 3, yeah. Okay, and so this is going to be 24 root 3, and then minus, so then as for 9, the square root of 9 is 3 to the 3rd, and that's going to be 27. Okay, this is the worst part about antiderivatives, honestly, is whenever you get nasty algebra expressions. This is honestly the worst part. So 24, we can divide that by 6, so 24 divided by 6 is, well, okay, so right now I'm distributing the 1/6. So that's going to be equal to 4 root 3, and already I can tell my answer is going to be C, then minus 27 over 6, but that would be 27 and 6 are both divisible by 3, that's going to be 9 halves, so there you go. Alright, okay, for 6 we're doing the same thing. So this one right here was a finite integral. This will be a definite integral. Or wait, vice versa. This is a definite integral. This will be a finite integral. But we're going to use substitution. So look at the top. I'm going to look at the bottom right here, and I'm going to see that this is 1 degree less than the denominator, which I'm going to then probably try to see if I can make this whole denominator my u substitution, considering that if I take the derivative, it might just be this right here, or something close to. So let's say that I allow u to be equal to 3x to the 3rd plus 12x plus 3. Now, wait a minute, that should be 9. That's, let me redo that. So let's, I'm gonna let u equal 3x to the 3rd, sorry, I jumped the gun right there. 6x squared plus 3x plus 5. And du dx, we're going to say, is equal to 9x squared plus 12x plus 3. And then I can factor that. I can factor out a 3, and that would be 3x squared plus 4x plus 1. And that right there is my numerator, which is good because I think I can get those to cancel if I solve for dx here. So if I solve for dx, dx is going to be equal to du all over 3x squared plus 4x plus 1. Okay, and so let's make our substitutions. We have the integral of 3x squared plus 4x plus 1 divided by u times by du over 3x squared plus 4x plus 1. And then, yeah, so obviously those are going to cancel, leaving us with a pretty simple expression. The integral, 1/3 integral of 1 over u du. So what derivative gives me 1 over x? Natural log. So hopefully you guys catch that. So this is actually going to be 1/3 natural log of u plus c. And undo the substitution. So this will be 1/3 natural log of 3x to the 3rd plus 6x squared plus 3x plus 5 plus c. So I think that's going to be C. Okay. All right. And then looks like we have a free response. We have the figure of f, and we have regions A, B, C, and D, so A, B, C, D, and E, and they have areas 5 to 16, 5, and 6 respectively. So I'm just going to throw those in there. So we have 5, this right here will be -2, C is going to be 16, D is going to be -5, and E is going to be -6. Okay, and so for -7 to 9, the function g is defined as such right here. And so g is using the antiderivative of f, so there's got to be a relationship between these right here. But as far as a goes, it says, is there a value of x between -3 and 2? So between -3 and 2, is there a value such that g of x, notice that this is f, so for g of x is equal to 0. And so this is sounding like the intermediate value theorem, which hasn't come up in a long time. I know that we kind of talked about it in the last test, but we didn't really use it. We just kind of defined it again. But in this case, we're actually going to use it. And so what I want to prove, I want to see if it's possible to prove that g of -3 is either less than or greater than 0. And then, so let's say that g of -3 is greater than 0, but g of 2 is less than 0. Because f is continuous, and does that mean that g is also continuous? I hope so. I hope that means that it's also continuous. I think it is, because g is defined with f right here, and f is continuous, so would -6 be. So I'm pretty sure we can say that g is continuous. And so all I need to prove is that it crosses, that it will have to be 0. So what I'm going to do is I'm going to evaluate g of -3. So g of -3, if I plug in -3 for the x spots right here, g of -3 is going to be equal to -6 plus the integral from -3 to -3 of f of t dt. Well, I know that an integral over a interval of 0 is 0, so this will be equal to just -6 plus 0. And then let's do g of 2. So g of 2 is going to be -6 plus the integral from -3 to 2 of f of t dt. So that's going to be equal to -6, and then let's check this here. So from -3 to 2 of f of t, so from -3 to 2 of f of x is 16. That's all that area. So then it's going to be plus 16, which is going to be equal to 10. So yes, because g is continuous, by the intermediate value theorem, g of x must equal 0 between between -3 and 2, because g of -3 is less than 0, and that's greater than g of 2. Okay. All right, for B, find the absolute minimum value and the absolute maximum value. So absolutes, so that's sounding a lot like the candidates test. And so if I'm, oh my gosh, yeah, candidates test. So we have endpoints from -7 to 9 on G. Now we need to find the critical point. So we need to find when g prime of x equals 0. So g prime of x, the thing is, so let's take the derivative of this. The derivative of -6 is 0, and the derivative of this, because it's already an integral, is just going to be f of x. So you can see here that g prime of x is equal to f of x. So this is the graph of g prime of x. And so that means that I just need critical points. So when that equals 0, that's going to be at x equals -5, -3, 2, and 6. So these are the critical points, and we have our endpoints. So we got to make a table. So this is kind of going to be the, not going to lie, an unpleasant part of this all. So we're going to have x values, and we're going to put these into g of x, because we're trying to find the maximum value of g. So we've got -7, we've got -5, -3, 2, 6, and 9. I don't think they gave us enough critical points. Gosh dang it. Okay, that's fine. So, g of -7. So let's plug in -7 here. So, man, -6 plus the integral from -3 to -7. So from -3 to -7, I'm going to flip those to be -7 to 3 and change that to minus. So minus the integral from -7 to -3 of f of x, of g of x, sorry, of f of x, yeah, of f of x, of f of t dt. Doesn't really matter, t is a demi-variable. So that's going to be equal to -6 minus, so from -7 to 3, the total area is going to be 3. So that should come out to be -9. So -9. Okay, and then let's do -6 minus the integral. So from -3 to -5. So I did minus again because I'm going to flip those. So that's going to be -5 to -3 of f of t dt. That's going to be -6. And from -3 to -5, the area is -2. So that's going to be minus -2. So that should come out to be -4. And then for -3, so we're going to have, that's going to be 0. Right? No, it's going to be -6 plus 0, because if I do the integral from -3 to 3, that's going to be that right there. Also, didn't I already solve for g of -3? Yeah, I already solved for g of -3. So that's going to be equal to -6, and I already solved for g of 2. That's 10. And so that's going to be 10. And then for 6, that's going to be -6 plus the integral from -3 to 6 of f of t dt, and that's going to be equal to -6. And then from -3 to 6, that's 16 minus 5, which will be 11, so plus 11. So that's going to be equal to 9, right? Minus 5. Oh, wait, what the heck? Not mine. Oh, what the? This is embarrassing. So 11, that's going to be, is that going to be 5, right? Okay. And then for here, we'll do -6 plus the integral from -3 to 9 of f of t dt. That's going to be equal to -6. And then from -3 to 9, that's going to be 16. 16 minus, 1 second, sorry, just thinking about something. 16 minus 5. Yeah, which will be, 1 second. Checking my work for the previous one. Yeah, okay, so, yeah, -6, that's going to be plus 16 minus 5 minus 6. And so that's going to come out to be equal to -1, because 16 minus 5 is going to be 11. Yeah, okay, so -1. And so what's the absolute maximum value of the function? So the absolute maximum is going to be 10, right? So the absolute maximum is going to be 10 at g of 2, right? And then the absolute minimum is going to be, is that at negative 7? G of negative 7, which is equal to negative 9. Okay, so that one was fun. Alright, and took up all my space. Cool. Alright, for this one right here, for part C, so just the integral of that right there. So that's going to be equal to, I'm just finding the antiderivatives. That's going to be x squared plus 16x plus c. That's easy enough. And for this next part right here, find the value of the integral from negative 7 to negative 5 of f of this. So this is using a u sub. So let's let u equal 2x plus 16, and that means du dx would be equal to 2, which means dx would be equal to du over 2. Okay, so then we'll do the integral from negative, again, I know you guys might hate it. I like switching out my bounds, so let's change these to be in terms of u rather than x. So if I plug in negative 5 right here for my u function, so if I plug in negative 5, that's negative 10 plus 16, so that's going to be 6. And then if I plug in negative 7, that's negative 14 plus 16, that's going to be equal to 2. And then we're going to have f of u du over 2. So that's going to be equal to 1/2 integral from 2 to 6 of f of u du. And now we know what the function f is. We have the function f right here. So this will be equal to 1/2 and the integral from 2 to 6. The integral from 2 to 6, which is negative 5. So times by negative 5, which is going to be equal to negative 5/2. And there we go. Alright, as far as this next part, I think I'm going to do a separate video for that one.